and welcome to lesson 2F. I can write two-column proofs, proving two triangles to be congruent. So looking at this, we are going to use our new triangle congruency laws to help us prove two triangles to be congruent. My suggestion is you start every single proof by looking at what you're given and if you can add anything to your drawing and making a plan. So here I'm given two sides congruent. That's AB happens to be congruent to ED, and again, I'm watching the order in which I'm writing things. I'm given two angles congruent, angle, that's angle B congruent to angle D. Okay, that's all I'm given, but I think I can actually add to this diagram some. When I'm looking at this, I see I have a vertical angle here, right? And so that would add another angle to my diagram, which would mean that my plan is to prove the triangles congruent by AAS. So that's where we're going. That's the plan. So now let's actually do the proof. Let's put that there. All right, let's actually do the proof. All right, so we always do statement and reason as always. Well, the first thing I do is I write the givens. I write my givens, and those givens again were a side and an angle. So I'm just kind of noting that on the side to help me keep track. Then I add information if I can. The information I get to add is that angle BCA is congruent to angle DCE because of the vertical angles theorem. And again, I'm watching the order in which I'm writing things. I cannot call that angle C congruent to angle C because angle C could be four separate angles. So we have to give it a three-letter name. And so that then allows me to prove my triangle's congruent. I'm able to prove triangle ABC is congruent to triangle EDC by the angle side theorem. And that's the end of my proof. Easy as that. Let's look at the next one. All right, so we always start off by looking at the diagram and seeing what we're given. So we're told that GI is the perpendicular bisector of FH. So I'm going to mark that up. If GI is the perpendicular bisector of FH, then that's 90 degrees, and those are both congruent. Well, if that's 90 degrees, I know this is also 90 degrees. And I see we have a shared side. GI is in both of my triangles. So I'm going to mark that as congruent as well. So looking at this looks like it's going to be S, that's an S, that's an S, that's an angle, that's an angle. That looks like we're going to use SAS to prove the triangle congruent. That's the plan. So now let's start. So we write our statement and our reason. We write down the givens. GI is perpendicular bisector of FH, reason given. And now we need to interpret what that really means. What it means to be a perpendicular bisector. Well, the word bisector tells me that FI, segment FI, would be congruent to segment HI. Because that's what bisectors do. They divide things into two equal pieces by the definition of bisector. And then the fact that it's 90 degrees tells me that the measure of angle GIF equals 90 degrees. And for that matter, the measure of angle HIG also equals 90 degrees by the definition of perpendicular. So do you see how we are able to take that vocab word and tear it into two pieces of information? Things are congruent and angles are equal to 90 degrees. Well, we then have a really nice theorem that we proved way back when you first learned how to prove, like your very first proof, which basically says that if two angles equal 90 degrees and they are congruent, angle GIF then is congruent to angle HIG, And my reason, I don't remember the name of it, but I can tell you that all right angles are congruent. All right, so now, so far we have proven up here, we proved a side, we just proved an angle. Ooh, hello. We just proved an angle. Now we need to prove the other side. Well, looking at this, that's that shared side, right? That GI. Well, it's on both triangles, but I can't just say that, I can't just assume that in the proof. I have to actually write that they're congruent in the proof. So I'm actually going to write GI is congruent to GI. Segment GI is congruent to segment GI to get my other S. And my reason, okay guys, think about all those lovely properties we learned when we have two things equal to itself, it's exact same on both sides. That's the reflexive property. And this time it's a property of congruence because we've got a congruent symbol. So guys, you cannot prove triangles congruent until you actually have gone and listed the three things you need. So at this point, I now can say triangle FIG, triangle FIG, is congruent to triangle HIG, and again, order matters, by side, angle, side. And it works because we did actually go through and we listed a side, an angle, and a side in the steps above, which allows us then to say SAS. So, and let's look at the last proof. Oh, this one's really cool, actually. So let's start off by looking at what we're given. L is the midpoint of GN, or JN. So if L is the midpoint of JN, then that means that these two things are going to be congruent. That's one thing I'm given. Angle KJL, that's this angle, is congruent to angle MLN, that's this angle. And then they tell me that KL is parallel to MN. So I'm going to mark it as parallel. KL is parallel to MN. Now, we actually get to use some of those parallel line theorems we learned before to add on to this diagram. So we learned when we've got two parallel lines, which we do, right? That's KL and MN, cut by one transversal, it's like JN, then the alternate interior angles are congruent. So that would mean that this angle would be congruent to this angle by alternate interior angles. So what ends up happening in this proof is I end up with an angle, a side, and an angle, right? Angle, side, angle. So my plan is going to be to prove my triangles congruent by ASA. ASA. So now let's work through our plan. So I start off by writing my three givens. And guys, my three givens only gives me one piece of information I need. Remember, I always need three pieces of information. Well, the only piece of information I've got right now is step 2, that those two angles are equal. So I've got an A. I need to pull another S and another A out before I can tell you that the triangles are congruent. Well, let's go ahead and take a look at the givens. If I tell you that something is a midpoint, well, midpoints divide segments into equal pieces, just like a bisector. So I can say that JL is going to be congruent to LN, and again, I'm looking at the order I'm listing these very carefully, guys, because of the definition of the word midpoint. Definition of midpoint. So that gets me my S. And now let's take a look at the information we derive from the fact that these are parallel. Remember, we did that in red up here. Actually, I'll switch that to red, shall I? That these are parallel. Because when we've got two parallel lines, then we're able to say that that the alternate interior angles are congruent. That's what I was able to find. Or corresponding angles are congruent. That's what I was able to find. So for step 5, I can say angle KLA is congruent to angle MNL. And my reason for that is the converse, remember these guys? Converse of the corresponding angle postulate. Yep. All right. That was my other A. Ooh, hello, did not mean to do that. That was my other A. So at this point, I have 3 pieces of information that happen to make my ASA pattern, so I'm now able to prove my 2 triangles congruent in my 6th step. My 6th step, I'm able to say triangle KLJ is congruent to triangle MLN by my theorem angle, side, angle. All right, guys. So that's the big idea in this lesson. Again, I want to remind you, you cannot write a triangle congruent statement until you have proven all 3 of these things in the step above. So this guy, we needed 2 A's and an S. Here, I needed to show 2 sides and an angle congruent, and we did it over here. And here, I had to show 2 angles and a side, and we did it here. So that's the key idea for these proofs. All right, guys, take a look at the MML exercises and have a great day.